Hi guys, it's Simon C. Welcome to this new AI radar. Today I have for you 3 news about advances in artificial intelligence. Popular mechanics contributor John Wentz reported that for the first time the manipulation of carbon in the lab at the atomic level has given birth to a cyclocarbon known as 18-carbon in a solid form. One area where carbon shows a lot of promise is in future electronic applications. Other atomic scale carbon, like graphene, has shown excellent conductivity with electrons hitting relativistic speeds, meaning that they are about to reach the speed of light. One area they may be applied is physical neural networks, which would power artificial intelligence brains in complex decision-making skills by modeling the outcome of a series of solutions to various problems. Most neural networks today are simulations of physical neural networks relying on a series of algorithms, but the researchers think they could use it to physically model neurons, an idea that stretches back to the beginnings of artificial intelligence research. Neural nets, whether physical or virtual, rely on overlapping processes connected together. To work on the same problem, they need to be able to make conclusions rapidly based on other interconnected processes, much like our own actions throughout the day are a complex aggregate of simple decisions. Many electronics built with cyclocarbon components could be physically connected together at the atomic level, tiny carbon neurons that create a true artificial brain. The staff of emerging technology from the arXiv reports that Carol Kurat and colleagues at Google Research Brain Team have created a soccer video game called the Google Research Football Environment to allow researchers to test their algorithms in a world that is physics-based, customizable, easy to use, and endlessly reproducible. They made this world available with an open source license so that researchers anywhere can use it to develop better soccer playing algorithms. Soccer simulators are key in teaching the machines to cope with unexpected actions typical of the real world, but in a controllable fashion. These simulators have certain levels of predictability based on the physics of game, but there is also plenty of unpredictability that arises from the tactics of opposing players, the mismatch between players in situations such as tackling and so on. So Kurach and colleagues have built their own simulator. The researchers have modified a publicly available gameplay football to provide a measure of success for machines, based on how closely the machine can maneuver the ball to the opponent's goal in a controlled fashion. The learning algorithm can play against other machines or against humans. This gives it experience with a broad range of strategies, and it avoids the scenario in which the machine simply learns the weaknesses of a machine-based opponent, which might not be applicable to games in general. It is likely that machines will learn new soccer strategies that humans have never considered, just as they did for Go. Thanks to this work. This work may also help machine learning work in more realistic environments. On the conversation, Carl Strathearn, PhD candidate at Staffordshire University, reports that he and his colleagues have designed a multimodal Turing test to judge a machine's appearance, movement, voice in what they call embodied artificial intelligence, EAI. This is basically a measure of how well artificial intelligence is integrated with a robotic body in order to express personality. This means the researcher can systematically compare a humanoid robot to a living counterpart. In this way, they can ask the question, can we build robots that are perceptually indistinguishable from humans? These approaches tend to compare the robot as a whole with a human, rather than breaking it down into its component features. The idea is to evaluate each area step by step, says Strathearn. As long as each feature is designed to look like it is part of the same body, same gender, age, and so on, then if an eye and mouth can individually pass the test, then they should also pass it together, he argues. This would allow a robot builder to assess progress as they go, to ensure each body part is indistinguishable from that of a human, and to prevent ending up with something that falls into the uncanny valley. Wow, undistinguishable is very hard to pronounce for me. Okay guys, it's all for today. See you next time with AI Radar. Bye.